A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. The topic for our today's lecture is statistical significance of the parameter estimated through ordinary least square method. Previously you have studied what is ordinary least square and how we apply ordinary least square to estimate the coefficient of regression line or to estimate the population parameter with the given sample data. After estimation, we state that now we have to gauge the reliability, goodness and statistical significance of the parameter which we estimated. Why we estimate the reliability? Because our sample, we estimate our coefficient from sample data. We estimate it for population parameter. We estimate the sample coefficient for the population parameter beta naught and beta 1. While beta naught and beta 1 are fixed, population parameter are fixed, while our estimated coefficient vary from sample to sample. If we take 100 sample out of the population, we will have 100 different estimates of the population parameters. The sample estimates are variable. They have their own distribution around the population parameter, but we will discuss this later in this lecture. We then stated there are three tests that we can employ, three methods that we can employ to assess the reliability, significance and goodness of the parameter estimated, and we have studied the first method, that is goodness of fit of the coefficient estimated, and we have tested the goodness of fit of the coefficient estimated through R square. We said the higher the R square, the higher the goodness of fit, and lower the R square, the loose fit will be the model, and the value of R square remain between 0 and 1. Then we have stated that the second test is standard error test. This is also called statistical test of significance of the parameter. Now today we will study what is statistical test of significance, what are the various tests that we can use in gauging the significance, statistical significance of the parameter estimated, why we use that, we will start today. And the third method, that is econometrical test, we will study in later lecture of heteroscedasticity, autocorrelation, multicollinearity, identification, endogeneity and various problems. Now we have taken previously the two variable model, where there is one is independent variable, that is x here, and what other is dependent variable, that is y here. You have studied these lecture in previous classes and you have taught by Sir Imran. This is a simple ordinary least square model where we have the population regression function. This is our population regression function. Y is equal to beta naught plus beta 1 x plus mu. Mu is random error, while beta naught is intercept, beta 1 is the slope, and x is independent variable. The population regression line, the regression line of population is we take the expectation, the mean of the population regression function. If we take the mean of this, the mean of this random term mu will be equal to 0, and the population regression line will become expected value of y is equal to beta naught plus beta 1 x. And then now, as we know that we cannot observe the whole population and we cannot estimate, we cannot have the population regression function and population regression line due to various reasons. We estimate the coefficients beta naught head and beta 1 head for the beta naught and beta 1. To assess the values of beta naught and beta 1, we estimate it through beta naught head and beta 1. We use beta naught head and beta 1 head to estimate the values of the population parameter beta naught and beta 1. The estimated regression function is y cap, that is estimated dependent variable estimated regression function, is equal to beta naught head plus beta 1 head x plus e, that is the estimated residuals. Again, the estimated regression line, we take the mean of this estimated regression function, the mean of this residual will be equal to 0, so the estimated regression line will be beta naught cap plus beta 1 cap x. This was our estimation process. We study from this slide. Since beta naught and beta 1 are sample estimates of the parameter beta naught and beta 1, we cannot directly observe beta naught and beta 1. That's why we estimate their value through beta naught head and beta 1 head. The beta naught head and beta 1 head vary from sample to sample. Of course, from a population you can collect infinite number of samples, and you may have infinite number of the beta naught head and beta 1 head for the beta naught and beta 1. Thus, beta naught and beta 1 are random variable and having sampling distribution because they are varying. They have sampling distribution around the mean. Their mean is equal to beta naught and beta 1, that is the population parameter. Again, the estimated regression line will not coincide with the true population regression. Yes, of course, we estimated a regression line and we have a population regression line. Both cannot coincide because we cannot accurately estimate the population regression line through the estimated regression line, because our estimated regression line is based on the sample data, a part of the population, so it cannot truly represent the population parameters or population regression line. How close, now question is, how close the estimated line come to the true line? That is the very critical question, that how our estimated line lies closer to the true line. The true relationship between x and y is measured by unknown coefficient bi's, that is beta naught, beta 1, fixed. These are fixed, while our estimate beta I heads, that is beta naught head and beta 1 head, are variable. They are changing from sample to sample, because beta i's mean that beta naught and beta 1 are fixed. They are not changing. They are fixed for the population, while our estimate beta naught head and beta 1 head are variable. They are changing from sample to sample. Then there is a chance of error. There is a big chance of error that beta naught head and beta 1 head will not coincide with the beta i's of the population parameter, and the estimated regression line may fall away from the true regression line. How the slope coefficient beta 1 is distributed normally around the beta 1, that is the mean of the all beta 1 head. That how we calculate the mean of the beta 1 head, that we take all possible sample from the population and we calculate the beta 1 head values for all the samples. We have n number of beta 1 head and we sum all the beta 1 head and divided by n, we will get the mean of the beta 1 head, and the mean of the beta 1 head will be equal to beta 1, that is true population parameter. So we can say that how the slope coefficient beta 1 is distributed normally around the beta 1. Beta 1 cap is normally distributed around the mean beta 1 and with constant 0 with the mean beta 1 and with the constant variance, and that constant variance, if it is standard normal distribution, that variance will be unity is equal to 1. So how close our estimates of beta naught head and beta 1 heads are to their population parameter beta naught and beta 1, and are the estimates are valid or not? must be gauged. We gauge the reliability and the significance of these estimates. And now you have grasped the concept that why we are going to test the statistical significance of the coefficients, because we have estimated these coefficients from the sample data, and sample data is a small part of the population, and the population parameter beta naught, beta 1 are unknown. These are the mere estimates, and of course the mean of the beta naught cap and beta 1 cap is equal to beta naught and beta 1, but they are normally distributed along with the constant variance, with the mean equal to beta naught and beta 1 and with the constant variance. Now it is necessary to gauge the significance of these coefficient estimated. There are 4 type of tests that we will use here to estimate the significance of these coefficient. Number 1, T and Z test. These all tests are based on standard error test. We can say we are going to study the standard error because these all tests uses standard error to evaluate the significance of the coefficients. The statistical significance of the estimated parameter is gauged through the T test and Z test. We use T and Z test to gauge the statistical significance or reliability of the coefficient estimate. Again, the second test that we use is confidence interval test, CI test. Again, the confidence interval test is also constructed to gauge the confidence interval and reliability of the coefficient estimated. The third test that we will use to estimate the reliability or validity and statistical significance is p-value test. Again, the p-value test is also calculated to assess the reliability and validity of the coefficient estimated. And last one is F test. This is not a Z test, this is F test. The F test, the overall significance of the estimated model is gauged through F test. We will use these 4 tests to gauge the statistical significance. Note, the test of significance that above we have discussed uses the following formulas of the variances and standard deviation of the estimated coefficient and the random term, error term mu. These formulas will be derived in the next lecture of blue properties. We will derive these in the next session of blue properties. Before going to discuss the blue properties, we will gauge the statistical significance through all these tests. And these formulas are given to you now, and we will derive all these formula in the blue test session, right? These formulas are that the mean of the beta naught is equal to expected value of beta naught, that is mean, is equal to beta naught, that is population parameter. Mean of the beta 1 is equal to expected value of beta 1 hat, that is equal to beta 1, that is population parameter. Again, the population, the variances formulas are also given. We will derive these formulas in the next session because I don't want to confuse you with the many concepts in one lecture, and that's why I take these derivation to the next session. The variance of beta naught, that is a square deviation. Expected value of beta naught cap minus beta naught square is equal to, that is the population variance of the mu into summation capital Xi square divided by n summation small xi square, right? The variance of beta 1 is equal to, that is population variance into 1 divided by summation small xi square. And how we estimate the variance of the mu, that is population variance that we used in these formulas. Population variance, the estimate of the population variance is equal to summation ei square. These are the residuals, sample residuals, divided by n minus k, where n is the number of observation, where k is the total number of parameters that are estimated in the model. For us, in our model, we have estimated only 2 parameters, so k will be equal to 2, right? So these are the formulas, and these formulas we will derive in the next session. We will use all the formulas to gauge the statistical significance of the estimated coefficient, and we will derive these formula in the next session of blue properties. Before starting to apply the T-Z test for the significance, we illustrate that when to use T-test, right, and when to use Z-test, as both T and Z test has separate table for critical values for acceptance or rejection. Now when we use the T test and Z test, what are their basic properties we study in the next slide. Z test and T test comparison table. These tests also called the standard error test, and these are also called parametric test. Why these are parametric tests? Because these tests follow the normal distribution, because the beta naught cap and beta 1 cap are normally distributed around their respective mean with constant variance. That's why these are called parametric test. There are some other tests. If the residuals are non-normal and the beta naught cap and beta 1 cap are not normally distributed along their mean and constant variance, so then we will use the non-parametric test of Wilcoxon. Is a very well known non-parametric test. So we discussed the Z test before. Z test is a kind of hypothesis testing. It is a kind of hypothesis testing. What it do? Which evaluate the estimated coefficients. Which evaluate what it evaluate that the estimated coefficient are equal to 0 or different from 0. Now what it mean that the estimated coefficient is equal to 0 or it is different from 0? It means Z test is a hypothesis testing procedure which evaluate that estimated coefficient is equal to 0 or not equal to 0. If the hypothesis state that the coefficient beta 1, let's suppose we take is beta 1, is equal to 0, then what will happen? Beta 1 is equal to 0. It's mean that the independent variable x will have no impact on y. It's mean the impact of the x is insignificant, and the coefficient is also insignificant because it doesn't it cannot do any impact on the dependent variable. So this is the basic concept. If it is proved through hypothesis that the estimated coefficient is equal to 0, example beta 1 is equal to 0, beta 1 hat is equal to 0, then we state that x variable, independent variable, is statistically insignificant in affecting the dependent variable. If through hypothesis testing it has been proved that beta 1 cap is not equal to 0, either it is positive or negative, then we state that x is significant in affecting the dependent variable. If it is negative, we state that it is negatively affecting the dependent variable. If it is positive, greater than 0, then we state that it is positively affecting the dependent variable. That we will do in the Z test and T test. We will do the hypothesis testing through Z and T test. Number 2, the population variance and standard deviation are known. Where standard deviation and variance are given. Yes, that's very important. It's mean that we will be given with the standard deviation and variance of the population parameters. The population variance and population standard deviation will be given. In only that case we will use Z test. Otherwise we will not use Z test. When we will use Z test? When the population variance and population standard deviation are known, or the sample size is big enough that must be greater than 30. In that case we will use the Z test to evaluate the significance of the estimated coefficient. Again, the Z test follow the normal distribution with 0 mean and variance equal to 1. These are the characteristics of the Z test. These are the important characteristics. There are numerous characteristics that you have been studied in the statistic 2 and statistic 1. but these are the important that we will utilize in our analysis. Now we coming toward the t-test. Both tests are parametric test. T-test is a kind of hypothesis testing that evaluate that the estimated coefficient is equal to 0 or different from 0, where the standard deviation and variance are not given. Here this t-test also do the same hypothesis testing. If the coefficient is equal to 0 proved, that it's mean that this variable doesn't impacting the dependent variable. If coefficient is not equal to 0, then we state that it is positively or negatively impacting the dependent variable. But one thing here, the standard deviation and the variance will not be given, that you have to calculate it from the sample data. You have to calculate the standard deviation and the variance from the model, right? And the population variance and standard deviation are unknown. Only the sample variance and sample standard deviation will be known, and you have to calculate from the formulas given above through sample data. Number 3, can be calculated for the small sample less than 30. Yes, if population variance and standard deviation is known, then surely you will use z-test. Again, if both are unknown but sample size is greater than 30, then you will also use z-test. If the population variance and standard deviation are unknown and the sample size is less than 30, then you will use the t-test. T-test also follow the normal distribution with mean 0, variance is not equal to 1, that is constant, but not equal to 1. These were the basic properties of the z and t-test. And now this was the introduction of that how we can test the significance of the estimated parameter. Inshallah, in the next lecture we will start from the t and z test and the procedure of t and z test. तब तक अल्लाह हाफिज़, अस्सलामु अलैकुम जी।